Okay, let's formally get started for today's lecture, week number 5, lecture number 1. So basically, for the last 2 weeks, we have been looking at different concepts which are related to objects and classes. And hopefully, we will be able to conclude this discussion today so that tomorrow we can see some relatively advanced topics related to classes, right? So for today, primarily we are left with within this topic we are left with three you can say subtopics. First, we'll see what is a constant member function, right? Then we'll discuss how you can use operators with objects, whether we are what are the operators that are allowed, what you can do, what you cannot do, and finally we'll see how you can pass complete objects as input to the functions, or you can return objects from functions, right? One of your colleagues also asked this in a previous discussion. So today that will also be addressed, right? So let's start with the first bullet, which is a fairly simple concept, right? But let's just discuss it for completeness, which is this constant keyword, right? So in your previous expertise or experiences, you must have seen this with data types, right? That normally when you are writing a program, so you can say int s is say 10. So now this s is something which has been assigned value 10 in the program, and now later you cannot change this value, right? So it is a constant, you can say identifier s. For example, later if you try to change its value, say s is s plus 2, so it will not allow you to do that because you cannot change the value of a constant integer, right? Normally you must have used this, I hope, with an array, right? Because normally when you are defining an array, so the size of array has to be constant, right? So rather than directly writing 10 here, it's a good idea that we define a constant integer and then we use s, so that when you are using loop later on, you change this 10 to 100, so you don't have to change all over within your program, right? So this was the general idea, that how you use constant with data, right? But what we are going to see today is using this keyword with functions, right? Which is something maybe new for you, but it's a fairly simple concept, right? So in order to understand this concept, let me just make a class. For a change, let's make a different class this time. Maybe we want to make a class to model date, right? So the data members of this class should be day, month, and year, right? So day, month, and year. And then within public, maybe you can make a constructor, right? So I can write, say, day, and default, we can set a default date that if user does not give any value, we want the default date to be 1st January, say 2000, or any date that you like, right? And within the body, now you must be well familiar that this is something that we always do: copy the data in the data members. Okay. And I'll just make one more function, right? Maybe print function. So void print, in which we simply display these data members, right? So I'll quickly write to save time. See out date, sorry, not date, day, month, year. Let me just correct it. Okay, so you display the day, month, and year. Okay, so let me just complete this class. Yeah. Okay, now you see, you will similarly have other functions like the set function or any other function, whatever you want to do with a date object, right? So now you see, if you look at this print function, the objective of this function is to simply display data to the user, right? This function is not changing the value of the data members day, month, and year, right? Because it should not do that. It is only made so that you can display date to the user. On the other hand, this constructor, it actually needs to change the data members, right? Whatever values you are getting, this constructor will be actually changing, you can say, the data members. Similarly, if you have a set function, then you also need to change the data members, right? So in C++, you have a provision that if there is a function in which you do not want anyone to change the data members, you can make that function constant, right? And how do we do that? You have this function, you simply write the keyword constant here, const, just that. Now what will happen with that? Now print is a constant function, and this function, now it is not allowed to change the class data members. It means in this function, if you try to change the value of day, month, or year, the program will not compile. It will give you an error, right? So in short, in a single line, a constant function, if someone asks you what is a constant function, a simplest answer is a function which cannot change class data. When we say class data, it means this is the class data, these three variables, day, month, and year. Of course, if in this function you take some other variable like X, you change it, it's okay. There's no problem with that, right? When we say you cannot change the data members, we are talking about the data members of the class, which are day, month, and year. Okay. Now, this is how it works. So now the question is why we need it. Okay. What is the advantage of this? So you see, as I keep telling you that once you are working on some relatively bigger projects, so you have very complex classes, right? Maybe a lot of functions. So there are some functions in which you would not want that those functions should change your data members, right? So what actually happens is that if you are working on a team, maybe this is your team lead, okay, and then there are two developers. So what this guy will do, he will write the prototype of all the functions, and maybe he gives you a class date to write the definition of those functions, right? And in the prototypes, he can make some functions constant, so that maybe you are a junior developer, so he will not take the risk, and even if you accidentally try to change the data members, the program will not let you do it, right? And you must be thinking that why I would accidentally change a data member, right? At this stage, this statement sounds strange, right? That I am writing a program, I cannot do such a mistake, right? But the thing is that, you see, when you are coding from 9 to 5 with only 1 hour of break, and you are writing very complex programs, it is not always possible to maintain your concentration. It does happen, right? You will get to know when you actually do some real software development. So that's why there are always chances that you can accidentally change the class data member, right? So if the function is defined as constant, the program will give you an error and you will not be able to do that, right? So in summary, all the functions in which you do not want them to change data members, you can make them constant, right? But of course, you cannot make a constructor constant, because the objective of constructor is actually to update the data member. You cannot make set function a constant function, because you have this function to change the data. But yes, a get function or a print function, you can easily make it constant, right? Now let me show you this example by now the same concept, but by our you can say previous class, which was point, because we already have this class here. Okay, so I'll just maybe I'd already written it, so I'll just get rid of it first, so that you have your point class in its original form, right? So you see, this is our point class which we have been dealing. This is constructor, a print function, set function for x and y, get function, and a main, right? So you see, now what I can do, since this print point function, it only needs to print data, it does not, and it should not change the data. So I write the keyword const, which is short for constant. Okay, and Now, of course, if I run the program, it will run like normal. It will simply display the data members, right? But just to show you that if in this function, suppose I try to change the value of x, say x is maybe x plus 1, something like that. Okay. Now you see it is giving us an error. What is the error? Expression is not modifiable. I cannot change the value of x. Why? Because x is a data member and this function is constant. If you try to change the value of x, the program will not compile. It is giving you an error. So you have ensured that anyone who is writing the body of this function, if he or she even accidentally or intentionally tries to change the data member, they will not be allowed to do that, right? So this now, since we are not changing, we are only displaying the value, so this is okay, this is fine, right? So similarly, you see, if it is a constructor or a set function, then you should not make it constant, right? Because if you make it constant, then the objective of this function is lost. Set functions or the constructor, they should actually change the value, right? So all those functions in which you don't want any changes to data members, you can make them constant. Now let's quickly see an example in your slides, and then we move to the next thing, right? So as I told you that constant is a keyword that you can use with functions as well. And if your function definition is outside the class, as we had seen previously, then you need to put this keyword both in function prototype as well as function definition, right? At both these locations. So in short, you just put this keyword constant after a function, and for example, there's a class distance which has data member feet and inches. So now this function cannot change the value, right? So this is a, you can say, illustration of that, what happens if you try to change the value. So there's a function which is not constant, which is a regular function. There's a data member a, so you can change the value of a in the first function, but the second function is actually a constant function. So if you try to change the value of a, then it will not allow you, right? So now let's move to our next discussion, which is basically related to uh, operations, right? Operators. So we have already seen point class, so I will not be rewriting it. I'll just be writing the main, assuming I already have the point class, right? Suppose I have a point P1, which is say 2, 2. I have another point P2, which is like 4, 4. And I take another point P3, which is the default constructor, so it is 0, 0. Okay. Now you see, um, sometimes if with basic data types, right? Maybe if we have some basic data types, say x is 2, so I'm allowed to write a statement like y is x. Y gets the value of x. So the value of x is actually copied in y. So y will also become 2. Now let's see what happens if we do it with you can say objects. So it means that I should be allowed to write a statement like this: assignment operator with object on the left and object on the right, right? So what actually we have this is our P1, which is 2, 2. This is our P2, which is 4, 4. And then we have P3, which is 0, 0, right? Because the default constructor is called. So when you write the statement P3 is assigned P2, this is a perfectly legal statement. You can use assignment operator. And what does this assignment operator do? It will copy element wise the data into the object which is on the left side. So it means this X will go in this X and this Y will go to this Y. So P3 will also become actually 4, 4, right? So uh, the important point is that you are allowed to use assignment operator with objects of classes just like you used with structures, right? There's no problem with that. Okay, but other than assignment operator, things would be not so straightforward. So for example, with integers, you can add two integers like this, plus with the plus operator. Suppose you say I want to do this. I want to add 2, 2 and 4, 4, and I want to get 6, 6, and I want this answer in P3. So if you are dealing with integers or float, you have this plus operator. You write A plus B, you get the answer in C. So if you try to do the same thing with objects of classes, say P1 plus P2 gets P3, then it will not compile, right? It will give you an error. In the later weeks, we'll see how to actually achieve this. But as of today, you cannot use any arithmetic operator with objects, which means you cannot use plus, minus, multiply, divide, mod, anything, right? Similarly, if you try to do this, if P1 is less than P2, right? Again, you cannot do this. Less than, greater than, equal to, not equal to. So none of the relational operators can be used. The only operator that you can use with objects is the assignment operator, which is legal. So in short, other than assignment operator, you cannot directly use any operator with the objects of your classes. And it makes sense. Why it makes sense? Because you see, you have two objects, say P1 and P2, and you are trying to compare them, less than. So how would your program know that what are you comparing? Are you comparing X? Are you comparing Y? Or are you comparing both, or you are comparing something else, right? Because it's your logic, your business logic, you are developing it. So program cannot guess that when you write P1 less than P2, how you compare them. Similarly, suppose you have a student class, right? And you write S1 less than S2, you are comparing two students. So whether you are comparing their ages, you are comparing their date of birth or GPA or height or what, right? So your program has no idea. That's why it is very much logical that why these operators are not directly allowed. Similarly, a very common mistake that you normally won't do in a lab session because the compiler will complain, but when you are attempting an exam on paper, right, like a midterm exam or a final exam, so a very common mistake is that many students will do this, right? That if you have to display, you simply write C out. And less common is this one, like C in P1, right? But since C in is not very frequent, this is a very common mistake. Now you cannot do this. You cannot use C in, C out with objects or classes. And you cannot use with structures as well. Whatever we are saying, it is also applicable to structures, right? So if you want to achieve this, what you need to do, you can make a function p1.print or display. So you call this function, and in this function you are displaying X and Y, right? So please be careful. Other than assignment operator, you cannot use any operator with objects of classes. You cannot use C in, C out with objects of classes. If you want it, you make a function in the class and you do C in, C out with individual data members of the class, because those data members would be primitive data types like integer, float, character, or something else, right? So this is an important piece of information that you should take care of, right? Okay, so these were two basically minor topics. Now let's see the main topic for today, which is objects with functions, right? That you already know in detail what are functions, right? And we have already seen what are objects, right? So now we see functions with objects. Okay, this is an important topic, so please, I would appreciate your attention. And this topic will also actually help you to understand the subsequent, you can say, topics, right? So there's also a query by one of your colleagues that can we make a function which will add two objects? So we are exactly going to do that, right? That will be, since we cannot use the plus operator, but we'll make a function which will do that job for us rather than the plus operator, right? So it is exactly what I'll be showing you in this example. Okay. So since we are dealing with some examples which will include some arithmetic, so it's better that we go back to the point class, right? Maybe we can come back to the date or time class later on. But for the first example, this is the best you can say, or the simplest class which makes things easier to understand. So that's why we go back to our old point class, and you can assume that you have constructor, print, everything is here. Okay, so I'm not rewriting it because that will consume time. you assume that everything we always do, it is present here. Okay. Now I'll come back to this class later. First, maybe let me come to the main. Okay, so in main, again, suppose I take 2 points, point P1, which is 2, 2, and point P2, which is say 5, 5, and I take a third point P3. Okay, let me also plot these points so that you can visually see what is going on. So maybe this is our x-axis, this is our y-axis. So maybe this is our point 2, 2, and this is our point 5, 5. Okay, so this is actually P1 and this one is P2. Okay, now our objective is that we want to add these 2 points. So first we should know how 2 points are added. Every point has 2 components, x and y. For P1 we have this, for P2 we have this. So you know, when you add points, what you actually do is you add x components together and y components together. So it means I will get 7, 7. And this 7, 7 is itself a point, right? Maybe somewhere here. This is 7, 7. So the conclusion is that when you add 2 points, the answer is also a point, which is logical. When you add 2 integers, answer is an integer. So I'm adding 2 points. The answer is also a point, and we have also seen it through by plotting these points that how this will actually look like. Okay. Now let's make, since we cannot use operator as we discussed previously, so in the class, let's make a function which will add 2 points. Okay. So you have other things available. I'm only writing the function. You have rest of the things within the class. Okay. So I'm now writing the function. So whenever we are writing a function, we first think what should be the prototype of a function. Okay. And this function is, by the way, inside the class. Okay. I'm writing in the class. So for the time being, we say, okay, let's forget about the return type for some time. Let's give a name to the function. I call it add points. I have to add 2 points. So if we go back and we say, okay, what if I have to add 2 integers? When you add 2 integers, you make a function add, you pass the 2 integers as input, right? Which is the most logical way of doing it. So you say, okay, if I'm adding 2 points, then it makes sense that I should pass 2 points as an input, which I want to add, right? So just like you were adding integers, okay, just to remind you, I'll write in a corner. When you were adding integers, you were like add int, okay, because you are adding 2 integers. Now we are adding 2 points. So you just change your data type from int to point. Okay, so now let me write it. Okay, so here I'll write point A, which is my first point, and point B. Okay, so these are the 2 points which I want to add. Okay, now before when I will call this function, now let's go to the main and see how we'll call this function. Okay, since this function is inside the class, so in order to call this function, you need some object and then dot. Okay, so let me say I write p3 dot. Why I have written p3? Just ignore it for some moments. Add points. Okay, you see this add point function is inside the point class. I cannot call it just like structured programming, where you just write name of the function you call it. Whenever you call a member function, you need an object on the left side of the dot. So I have written p3 dot add, right? We'll come back to this later. The important part is what I should pass as an input. I want to add p1 and p2. So the input to this function should be p1 and p2. So this is just like what we do in structured programming, that we call a function, we give an input. Now what is actually going on? This p1, it goes to A. and this P2, it goes to B. Okay, just like it happens in a regular function call. So let me also you see draw them in the memory maybe. So this is our P1, which is 2 2. This is our P2, which is 5 5, and our P3 is 0 0. Okay, these are the three objects which are in the main. Now when you call this function, you must remember whenever we call a function, two new variables are created, a and b. Okay, and the value of p1 is copied in a and the value of p2 is copied in b, just like it happens in you can say calling the function with some basic data type. So a copy of p1 is in a, so it means a is 2 2, and a copy of p2 is in b, which is 5 5. Right, so I'll just make a discrimination between these. These are the variables in the main, and these are the two variables in the function, which are the local variables of this function. Okay, now you see within the body of the function, what was my objective? Our objective was we wanted to add p1 and p2. And how do we add p1 and p2? We add x components together and y components together. So it means I can write something like a dot x plus b dot x. What is a dot x? This thing 2. What is b dot x? 5. And we wanted to add them together. Okay, where do we store them? Just wait for a moment. Similarly, I can write a dot y plus b dot y. When I say a dot y, it means I'm talking about p1 dot y, right? Because p1 is copied in a. So I'm talking about this 2. And when I say b dot y, I'm talking about this 5. Okay, so we know we can add like this, but where should I store them, or how do I deal with the answer? I add them, I get 7 7, right? Okay, now for some time, let's forget about this add function. Let's say I have a print function in this class. Okay, and here I write cout x and cout y. And if I call this function like suppose p3.print, so you come to this function, these x and y, they belong to p3. It means it will print 0 0. Why? Because whenever you are calling a function, it is called for the object which is on the left side of the dot. So it means these x and y are of p3. We agree on that, right? Now see this function call. We have called this function with p3. So it means in this function, if I write x and y, they are actually x and y of p3, right? Because when I only write x and y, it means these are x and y of the object for which I am calling the function. So if on the left side of the assignment I write x and y, so this x is actually of p3. So what will happen? That x of p3 will get the value 7. Similarly, y of p3 will get the value 7. So I did not return anything from the function. I added p1 and p2 and my answer is saved in this variable p3 because I actually decided to do like that. Later on we will change it, right? Don't worry about it. And now you can write p3.print. It will have the updated value, which is the sum of p1 and p2. So the very important statement in this whole discussion is this part. The first point is that since now if in this function I am only writing x and y, they are x and y of p3 for this example. If I write a dot x, a dot y, these are x and y of p1 because p1 was copied in a. If I write b dot x, b dot y, they are x and y coordinates of p2 because p2 was copied in b. Another important point is that we said after dot you can only write something which is public. But you see, I am writing these statements within the class. And this is the reason that I am able to access private data with dot, but from within the class. And we have already seen that from within the class, anything can access anything, right? So don't think that when you are writing a dot x, x is private, how we can access it? We are allowed to access it because this function is inside the class. had this function been outside the class, then this would not have been a legal statement, right? Let me write this program first, and then maybe we can have your queries, so that maybe some of your queries will be addressed when I write this program. Okay, so I'll make exactly the same example in on the compiler, and then we'll see its output. Okay, so let me go back. We already have this class, which is good. So now within this class, I will add one function. Okay, and the objective is we want to add 2 points. Okay, so I'll write maybe I write it at the end. Okay, so that you can also see the main. Okay, so here I write void add points, right? We want to add 2 points, so I say point A and point B, and then we give the body of this function. Okay, so what I will do before writing the body of this function, it's a good idea that first you write the main. Okay, in the beginning, if you find it difficult to write directly the body of the function, when you write main, it will automatically give you idea how to write this function. So in the main, I take point P1, which is 2, 2, point P2, which is 5, 5, and point P3. Okay, I did not pass any values, so the default are 0, so it will be initialized to 0, 0. Okay. Now you see in the main, how will I call this function? I will call it like p3 dot add points p1 comma p2. Okay, so p1 goes to A, p2 goes to B, and if in this function I write x, for example, I write cout x, then this x is actually x of p3, right? Because the function is called for p3. So let me just write, what do we want to do? We want to add p1 and p2. So I add the x coordinates, okay, and I copy the value in x. Similarly, you can add the y coordinates, a dot y plus b dot y, and you copy the value in this variable y. And if we want to see whether it works or not, we can actually print points. Okay, so maybe I can print all the 3 points so that you know. I write cout p1, okay, and then I write p1 dot print point. Then I write cout p2 and p2 dot print point, and similarly for p3. Okay, so let me just run this program, and then I will come back to this code. Let me just write it in a way so that you can see the complete function as well as the main on your screen. Okay, so I'll run this program, and if it's fine, I'll show you the output. So this is your output window. You see, P1 is 2, 2, P2 is 5, 5. When we add them, we get the answer in P3, which is 7, 7. 5 and 2 are added, you get 7. 5 and 2 are added again for Y, you get 7. Right, so this is basically your output. Now let's go back to the program and convince ourselves that why we are getting this output. So let me quickly tell you again that when you are writing this function, this P1 is going to this A, this P2 is going to this B, right? So when you are writing A dot X, it means it is actually X of P1, right? And when you only write X and Y in this function, so when we call this function, we call this function with object P3, okay? So in the function, when you are writing X and Y, they are X and Y of P3. So since you are copying values in answers in X and Y, so actually you are copying your answers in the variable P3, right? So now you have seen an illustration that when you call P1 dot print point, you get this 2, 2, then this is 5, 5, and finally you get 7, 7, right? So this was, you can say, one way of doing it. There are other ways of doing it, like returning something, but we'll do it in the next example. But before that, if there are any queries, we can have a discussion session. Okay, now you see we are able to add two numbers, and why we did that, because we are not allowed to use operators, right? We cannot do P3 is P1 plus P2. So since we were not allowed to do this, we made a function which was doing the same thing. So now you compare these. Okay, so you see they look similar. Since syntax does not allow this, so we say, okay, we can make a function. We don't need your operator. We make a function add, which is adding these two and storing the result in this one. Okay. But now this is okay, this is perfectly fine, but maybe you can argue that normally when we are adding something, we expect the function to return something. Okay, that I get the answer, so that I use the assignment operator and I can copy that in, you can say, a variable. So we will do the same example, but this time we'll slightly change it. We will instead of the return type void, now we will try to return a variable, which again will be a point object from that function, which will also lead to slight modification in the function. So let me now, this was the problem, and now let me show you how do we do that. Okay, so again quickly, we have this class, and I will just write data, okay, because we have done it many times. So that's it. Okay, now within this class I will make a function. Okay, but this time from the function I will return the answer. When you add 2 points, the answer is also a point, right? So this is my return type, point add points. We discuss in a while what we should put here, and let's discuss it like this. Okay, I'll be filling it shortly. So again, before deciding how do we fill this function, we know that since this function has to return something, so I will have to take a point which is my answer. I will do something, and the last statement in this function should be return answer. Okay, it should be something like that, which makes sense, which is just like we do in case of basic data types like integer, right? Now in the main, suppose I have 3 points, p1, p2, and p3. I'm not writing them again. You just assume they are defined. This is main. So now when you will write p3 gets the value, okay, means answer will come in this, because we are returning this answer. So we want this answer will go in p3. And you will write add points. Suppose you say, okay, I will pass p1 and p2 to this function, just like you were doing previously. Then there's a problem that, okay, I also need an object here, right? You get the idea that because this function is in a class, so when you call a function which is in a class, you need an object on the left side of the dot, and the function is called for that object. Now we are using p3 here because this is the variable in which I will store answer. I want to add p1 and p2. Then there comes a question, then what I should put here? It does not seem a good idea that I take another fourth object, because that would be useless, you see, if we are using it. So instead of doing it, we do a slight, you can say, improvement on that. We say, okay, we will only be using 3 objects, right? But instead of passing 2 inputs to the function, I can also do something like p1 dot add p2. Now let's see what we are trying to do. In this function, I need access to x and y of p1. Okay, if I only write x and y in this function, they will be x and y of which variable? They will be x and y of p1. Okay, let me rather write them in a different color so that you get to know. So let me just write and then I explain. Yeah, suppose in this function I write x and y, so it means they are x and y of this p1, because I'm calling the function for p1. So I already have data of p1, and for p2 I can pass them as an input. So here I can write, say, point a, and within this function if I write a dot x, I am talking about p2 dot x, right? And a dot y. Now you see what is going on. Since I needed to add P1 and P2, I have written it as P1 dot add and P2. So I am passing only one of the operands as an argument, which is P2. Why I am not passing P1? Because when I call this function, I already have data of P1 available. If I write X and Y, they are X and Y of P1. So I don't need to pass them again, right? So to add two objects of point P1 and P2, I needed X and Y of both objects. When I call the function with P1, I already have X and Y of P1. The second argument, sorry, the second operand I am passing as an argument, so I also have P2. Now all I need to do is I need to store these in this variable answer. So I can write answer.x is this, answer.y is this, and I'm returning answer. When you return answer, what happened? Whatever is here, it goes in P3. So now you see it is exactly the same thing, but just a different way of doing it. Now we add this different function to our class as well. Since the arguments are different, so it can be an example of function overloading. So we don't need to change the name of the function, right? Let me just add that version as well. So we'll have both the version. We can call whatever version we like. Okay. Now, what did we say? Instead of return type void, you write point here. Okay. I'm keeping the same name, add points. But now instead of passing it two inputs, I am passing it only one input. Okay. And before we write the body of the function, I can write say point, this is my answer, and then I will write return answer. And in between, I will give a valid value to this variable answer, right? Now let's come back here. Now, instead of this statement, maybe I don't delete it, I just comment it. Okay. What we'll do, now we'll call the function like P3 gets the value P1 dot add points, and I pass it only one argument. Okay, now what will happen? Let me just annotate and tell you. So this P2 is going to this A, right? And when you are calling this function with P1, so if you write X and Y in this function, they are X and Y of P1, and answer P3 you will return, you will get P3 will get value from answer when I return this answer. Okay, so let's just complete it. So within the body, what we write answer.x gets the value X plus A.x. X is actually X component of P1, A.x is X component of P2. Similarly, you write answer.y gets the value Y plus A.y. Okay, and now we'll run this program and we'll convince ourselves that it gives us the same output which we were getting with the previous version of the function, right? So let me run this program, show you the output. So I hope you can see the output screen where again we are getting the same output. We are doing the same thing. 2255, when you add them, you get a third point, which is P3, which is the result of adding these 2 points, right? So let me show you the same example in the slides, and then maybe we can have a discussion, right? Okay, so this we have already discussed. I'll come back to this later. Yeah, this is our class. Okay, so we have a class point, two data members, a constructor, default constructor, a parameterized constructor, everything which you need, right? And then we have an input function, a print function, and then this is the function add points, right? So this is the first version where we are not returning anything. We are just passing 2 points and adding them, right? So this is the code that you will have. Okay. So in the example, I give the body of this function inside the class. For the sake of discussion, I have its body outside, so that's why I'm using scope resolution operator, right? If you put this inside the class, you can actually get rid of this. Okay. Anyways, so when we call this function, this is our first argument, second argument. You add X components together, Y components together, and when you are writing this, so actually you are calling the function like this: add points, and you are passing P1 and P2. Okay, so this is the first version, and you can take different points, you can add them, and you can convince yourself that it is working fine. Similarly, as I told you, there's another way that you can use, you can return something from the function. So in this case, you will call the function like this: P1 dot add P2. In this case, this P2 goes here. These X and Y, they are actually X and Y of this P1. You add them together and you store your answer in a variable result, which you return. When you return it, the value is copied in this variable P3, right? So this was adding 2 points. um, I'll go back. I'll quickly go through this example which I skipped. This example is basically showing you the use of assignment operator, right, which we discussed a little earlier. This is your date class constructor, setting the default date to 1st January 1990, a print function, a data member, day, month, and year, right? And then these are the definitions of the function, the constructor, the print function, and this is the main, right? So in the main, you see we have a date object, which is 7th April 2002. And we have the second object in which we don't pass anything. So it is the default constructor, which is called, which sets the date to 1st January 1990, right? Now we print date 1 and date 2, and then we use this assignment operator, right? That we can copy an object into another object using the assignment operator. So when you now call the print function, so you see previously it was 7th April, it was the default value, but when you use the assignment operator, you have this updated value of date in this and this variable G2, right? So this was showing you an application that or an example where the use of assignment operator with objects is demonstrated.